Hey guys, here's the part 2 for the credit recovery and marking period 1. We're going to be talking about direct proportions. Now, two equations that we used a lot during this section is y equals kx and k equals y over x. And we're going to be using those formulas throughout this video. So the first thing that we can talk about is how to identify a direct proportion. When given a table, we will be using the formula k equals y over x. And I'll take each y value and just divide it by the x value. So I'll do 40 divided by 2, which I get 20. 80 divided by 4, which I also get 20. And 120 divided by 6, which is also 20. Because these three numbers are the same, that means we have the same k value. That means that this table does represent a direct proportion relation. If we look at our second table here, I would take 160 and divide it by 2, 120 and divide it by 4, but I'm seeing that these two guys are not the same number. Because they are not the same, that means our k value is not the same for each one. This one does not represent a direct proportion. When given a graph, you can ask yourself these questions. Is the graph a straight line that passes through the origin? If you look here, it does cross through our origin right there, so that's a yes. So does it represent a direct proportion? Well, it has to go through the origin, and there's something else too. It has to be a straight line, which we can see ours is. So yes, it does represent a direct proportion. And we're able to use the graph to find out what our constant proportionality is, or our k value. We can just take one ordered pair on the line. For example, we have 1, 2. And we can use the formula k equals y over x to find out what our constant proportionality is. An ordered pair is usually written x comma y. So in this problem, my x value is 1 and my y value is 2. So I would be doing 2 divided by 1, or 2. If I wanted to write an equation, I can say y equals 2x. Looking at this graph here, is it a straight line? Yes, it is. Does it cross through the origin? No, it does not. So this is not a direct proportion. When given an equation, we're really trying to see that it matches up with the form y equals kx. So you have some variable equals to a number times x, and then that's it. So if you look at our first equation here, I have p equals 0.25q. That one looks exactly like this form right here. So yes, that is a direct proportion. Y equals 4x is also a yes. You can see that my k value is equal to 4. We're good. 2y equals 6x. Now looking at this right now, I would say no, it's not, because our y shouldn't have a number with it. However, I could divide both sides by 2 to cancel that out. Now I get y equals 3x, which is written in my direct proportion form. So yes, this is a direct proportion relation. And then with my last one, this one is a no because I am adding 12. If you look at my form here, there's no plus signs in there. I'm just multiplying numbers together. So this one's a no. All right, our word problems. Y is directly proportional to x, and y is equal to 9 when x is equal to 3. We want to write a direct proportion equation that relates x and y. So a big thing that we want to make sure that we're looking at is that y is directly proportional to x. So our equation in the end should look like y equals kx. Now I'm going to use these values that they gave me to find out what k is equal to. So I'll take my y value 9, divided by my x value 3, to get what k is equal to. Now that I know k, I can go ahead and just substitute that value in for k, into k here. Y equals 3x. The time taken to cycle a particular distance varies inversely. Oh no. Oh, we don't have to do this problem. Sorry, guys. Can we do this problem down here? All right. The height of a seedling is directly proportional to the number of days since it was planted. The graph shows the height of seedling H centimeters after X days. A huge thing here is we know that the height of seedling is directly proportional to the number of days. So when forming my equation, I know that my y is going to be talking about the height of the seedling, and my x is going to be talking about the number of days. And when looking at the graph, you can even see that. We have my y-axis, which they're using h, is the height of the seedling. My x-axis, which they are using x, is the number of days. So it says we need to find the constant proportionality, and then what does that value represent in this situation? Well, just like in the problem earlier, we can go ahead and take my coordinate point here, or this one here, or this one here, any of these coordinate points on the line, to find out what my k is. So I'm going to use the point 1, 2. Using k equals y over x, I'll go ahead and divide those two numbers. So I know that my k is equal to 2 divided by 1, or 2. Now, what does that mean in terms of this, the situation? Well, I have 2 centimeters that grow every day. So every 1 day, it grows 2 centimeters. Write a direct proportion equation. So I'm going to take my k and substitute it into y equals kx. However, I do it to make sure I watch my variables. So I'm not going to be using y because on the graph here it's saying to use h. So I'll say that h is equal to 2x. C. Explain what the point 510 represents in this situation. 510. Well, remember when we write these, it's x comma y. So my x value is 5, my y value is 10. So that means on 10, oh, not on 10 days, what are you doing? In 5 days, the seedling grows 10 centimeters. And then finally, the last two questions down below. What is the height of the seedling after 3 days? I can go ahead and look on my graph. 3 days is right here. Where does it meet the line? At 6 centimeters. After 1 week, what is the height? So 1 week is 7 days, so I'll go over to 7, go up to where it meets my line, which is right here. My answer is 14 centimeters. How many days will it take the seedling to reach a height of at least 18 centimeters? So I can go over to 18 here. Whoop. Where does it meet the line? Right there. And that takes 9 days. 9 days. There we go. All right, go ahead and continue the assignment on Schoology. Okay.